Let's determine whether a piecewise defined function is continuous at a point. All right, here's our function. F of x is equal to x squared minus 1 all over x plus 1 if x does not equal negative 1. Then the function will equal 6 if, in fact, x does equal a negative 1. We need to determine whether or not this function is continuous at the point a equals negative 1. Now, the first requirement for continuity is that the function must exist at that point. So we'll evaluate f of a negative 1. When x is, in fact, negative 1, we obtain a value of 6. So we satisfy our first requirement for being continuous at a point. The second requirement is that the limit exists. We'll take the limit of f of x as x approaches a negative 1. We see that in this case, our denominator would be 0 if we were to evaluate. So what we'll do is use a factoring trick. We'll take the limit, again, as x approaches negative 1, factor the numerator into x minus 1 times x plus 1 all over x plus 1. These factors will reduce out, and we can evaluate the limit further. Plugging in a negative 1 for x, we obtain a limit value of negative 2. Now, the third requirement is that the limit itself must attain that value at negative 1. But for our purposes, the limit as x approaches negative 1 of f of x equals a negative 2. Obviously, that does not equal 6, which is our function evaluated at negative 1. So we can say that this function is discontinuous at the a value, in this case, a equals negative 1. So this is not a continuous function at that point.